Welcome back to the last video of week 2. Alright, so in this particular video we are going to learn how to write electronic configurations in a box format. Okay, so let's write the title: Electron Configuration in a box format. This is something you probably have seen. You probably will see on most of your board exams that you might take when you're ready to graduate, whatever your medical profession program is. There's a 15% general chemistry component in your board exams. Okay, 15% general chemistry, bare minimum. They can ask more, but there is a 15%. Whether you take a MCAT, pharmacy, nursing, they all have a 15% general chemistry. And if I forgot to teach you this here, you'd get there and you see electronic configuration in box format and you'd wonder, well, my instructor never told me this, so I'm just going to leave it, and then get really frustrated that you never heard me say that. All right, so to understand this, let's go back to our fundamentals. Okay, as I said, this is my orbitals and this is the max number of electrons. I'm just refreshing your memory because it's few videos back. S can hold 2, P can hold 6, and all you got to remember is there's a difference of 4, so it's 10, and F is 14, right? And let's write a configuration for sodium, regular configuration, which is 1s2, 2s2, 2p6, 3s1. Now our box format is not going to be any different, but you do have to take into account that these 6 electrons, say in the p orbital, are not all put into one box. Okay, that's because there are 3 p orbitals. Okay, a orbital itself, a box orbital, can hold only 2 at a time. Only 2. Actually, I should say a suborbital. Okay, forgive me. A suborbital can hold only 2 electrons. Okay, and D is got. Oh, sorry. Let me erase it. What I meant to say was there are 5 d orbitals, or suborbitals is what I'm trying to say. I guess when I do my example it'll make more sense. And there's 7 of f orbitals, suborbitals. Okay, so what I'm really saying here is this right here is correct. Okay, this is the general electronic configuration. Now if you're going to do the box format, okay, I'm going to switch to different colors so it's not all black here on the screen. Okay, what I'm saying here is every time you see a P, D, or F, you got to make that many boxes. So 1s, no problem. Okay, I'm going to just write one sub. This is just one box. Okay, 2s, you didn't see me say how many there is, so there's only 1 boxes. The 2p is 6, right? P is got 3 suborbitals. Okay, so it's not just one box, it's 3 boxes, 1, 2, 3. Okay, and then there's 3s. S is always only 1 box. Okay, 1. Now it's important that each of these boxes are known as suborbitals can only hold 2 electrons maximum. Okay, so you write one arrow above for 1 electron and the other arrow down for the other electron. So if there is 2, that means you write 1 up arrow, 1 down arrow. Okay, there's 2, so you write 1 up arrow, 1 down arrow. Here is 6. Here is very important. You cannot fill all the 6 into this or this or this, but you must first go write 1 up arrow in all of them. And then so we've used 3 out of the 6, so we come back and fill the remainder with the 3. So you must, if there is 4, first you must fill each with 1 and then start again from the left, fill 1 more. Now in this case it's 6, there's so no problem. Here it's only 1, so it's up. Okay. So this is how, let's do one with the D, and probably I don't want to do F because it's all the same business. Okay. So let's pick one where we do have a D orbital. All right. So let's delete the screen. I'm going to come back with say, let's pick our periodic table and pick an element that's in the transition metal. So say manganese 25, or maybe not manganese. Let's do say cobalt. Okay, cobalt is 27. Okay, that means first write your general configuration. So 1s2, 2s2, 2p6, 3s2, 3. I'm writing the corrected configuration, by the way, because we are dealing with D shell elements. So it will be, I believe it is cobalt would be 1, 2, 3, 4, 5, 6, 7. So it's 3d7 and 4s2. There we go. This is the corrected version. If you are not still sure, then you got to go through and write the incorrect version and flip, and then make sure all 3's are with 3's, all 4's are with 4's. Now let's go ahead and write our box configuration for cobalt. I might use more space because I do want to make sure that I'm going to rewrite this with plenty of space so I can write my boxes below. Now, I mean, ideally you would want all boxes in the same row, but because I'm on a virtual tablet, I may not be able to, do this as good as, I'm going to just write my 4s here just to make myself more room. All right. So S is just one box, S is just one box. P, I said there are 3 suborbitals, so you've got to draw 3 boxes here. S again is 1 box, P again is 3 boxes. D, I said, has got 5 suborbitals, so it'll be 1, 2, 3, that's 4, and 1 more, 5. Okay, and then S again is 1 suborbital. All right, so now let's start filling. You should always have, this cannot hold more than 2, and you should have 1 up and 1 down arrow if there's 2 electrons. So that's, let me erase that. I made a mess of it. Okay, so that's 2, that's again 2, 6. Now I'm going to do it systematically even though I know what I'm doing. So it's 3. You first fill each with 1, however many you have, and then you come back and fill the remainder. So 6, and then this has got 2. This is 6 again. 1, 2, 3, 4, 5, 6, 7. That means first you got to go fill all with 1 out of the 7. So I can put 5 in the first go into the 5 boxes. Now I'm left with only 2. So that means I'm going to stop right here. You can however put that 2 down arrow in any of the 5 boxes, but it's conventional to put it in the first 2. And again, I am going to come back and finish it up with this. So this is an easier way of doing it. People do it this way specifically for teaching something else, okay? But it is assessed on board exams. So even if you don't do it for chemistry's sake, you should do it for your sake, because if this question were to be on your board exam and you don't know how to create a box diagram, then more likely you're going to be stuck. So the thing here is, in a regular configuration, we don't make that difference of the 3 suborbitals or 5 or 7, whatever many. But in the case of a box configuration, you do have to make that difference. And let me summarize it with a different color so you have that information. Okay, so P, okay, P has 3 suborbitals. Okay, Okay, D has got 5 suborbitals, okay, and F has got 7 suborbital, and each suborbital can only hold a maximum of 2 electrons with opposite spin. This is one spin and this is the other spin. Okay, you must first go fill each one with up arrow and then come back where you started to fill the remainder of the electrons with the down arrow. Well, that's it, folks. We're done with week 2 material, and the week 1 quizzes and homeworks will only contain material from week 1 and week 1 material, and if there is any cross contamination of week 2, please bring it to my attention. I can make sure that doesn't happen, but as far as I know, I haven't done the cross contamination of week 2 into week 1, but this is week 2 and I will be posting a quiz and a homework to go with it, which would be based on week 2 material. All right, so that's pretty much it. We're wrapping up week 2. All right, so the next time I will post video, it will be on week 3. All right, so this is end of week 2. Let me actually say that here, end week 2. That's official. All right, so if you see any other questions that's not been addressed in the agenda covered on week 2, more likely you got to bring it to my attention. Said, oh, that might be week 3 and I don't think I learned this material, and I can probably waive that question from that quiz or homework or whatever it might be. All right, so good luck learning, and if you have questions, please feel free to email me, as that's our primary source of contact. Good luck. Bye-bye.